Okay, so here's some more challenging inequality problems. And I'm going to suggest a way to do these problems that makes them a lot easier. It might seem like there's an easier way to do them when you first try them. But as they get more complicated, just try to understand this method. It's really helpful. And here's when this method works. It only works under specific circumstances. When you've got a product and you're comparing to zero. You've got a product and you're comparing to zero, okay? Or when you've got a product and a quotient. So you've got two things multiplied on top and dividing by something else, and you're comparing to zero, okay? It was here, again, two things multiplied, and then you're dividing, comparing to zero. Okay, here we're not comparing to zero, so that's going to be more challenging, okay? Now, the reason this works is because we know we've got this quantity and this quantity. We know this quantity has to be less than zero. Okay, so we don't know if this is positive or negative. We don't know if this is positive or negative. But we know if they're both positive, we get a positive. And that won't be less than zero. If they're both negative, we get a positive. And that won't be less than zero. Okay, so what we're going to do is we're going to make a chart. Okay, we want to know when this product is negative. Because when this product is negative, we know we're going to get something less than zero. So I'm going to draw out our number line, our critical values. The values with this factor changes from positive to negative is when x is negative 1. And with this quantity changes from negative to positive is when x is positive 3. So we've got a positive 3. Those are our critical values. I'm going to put open circles there. And over here on the left, I'm going to put the factors, x plus 1 and x minus 3. I'm going to divide this number line into intervals. Okay, so when x is less than negative 1, what happens to this quantity? When x is less than negative 1, I get, let's just pick something. Let's say x is negative 2. Negative 2 plus 1, I get a negative. Negative 2 minus 3, I get a negative. Okay. Now, when x is anything between negative 1 and 3, let's say 0. When x is 0. When x is 0, this quantity is going to be positive. When x is 0, this quantity is going to be 0 minus 3, negative. Okay, pick a number greater than 3 to test this interval. Say 4. X is 4. 4 plus 1, positive. 4 minus 3, positive. Okay, so anytime we're in the interval where x is less than negative 1, we've got a negative times a negative. Negative times a negative gives you a positive. Anytime when x is between negative 1 and 3, we're going to have a negative or positive times a negative, which is negative. And anytime x is greater than 3, we're going to have a positive. This will be positive. This will be positive. We get a positive. Okay. Which one satisfies this inequality? Well, that's when it's negative. Negative means less than 0. Okay, so solving this on the number line, we simply have this interval from negative 1 to 3. Or in set notation, set of all x such that x is between negative 1 and 3. Or you could do negative 1 to 3 if you want to do interval notation. Now let's do this one. Same idea. Make our number line. Where's our critical value? What value of x makes this quantity 0? If you can't see it right off, solve it. So do 5x minus 2 equals 0. Solve for what value of x makes this quantity equal to 0. So 5x equals positive 2, and then x will equal 2/5. So we've got 2/5, positive 2/5. And then this critical value here is going to be when x is negative 1. Let's set up our factors. Okay, split up the number line. When x is less than negative 1, let's say negative 2. 5 times negative 2, negative 10. So that's negative. Negative 2 plus 1, negative. Pick a number between negative 1 and 2/5. So 2/5. Say 0. 5 times 0 minus 2, that's negative. 0 plus 1 is positive. And when x is bigger than 2/5, let's say 1. 5 times 1 minus 2 is positive. 1 plus 1 is positive. Okay? A negative, this represents a negative times a negative, which is positive. This represents a negative times a positive, which is negative, and a positive times a positive, which is positive. We want greater than 0, greater than or equal to 0, so we want the positives. Okay? So we're going to put a circle here, here. We're going to include both of these because that's or equal to. So our solution on the number line looks like this. Solution set of all x such that x is less than or equal to -1, or x is greater than or equal to 2/5. Okay. You want to do interval notation, you could say negative infinity to -1, include the -1, union with 2/5 to infinity. All right. Okay. Next one. Now there's something a little more tricky in this next one. Notice there's a little bit more to it. There's 3 quantities we're comparing, okay, but we're still going to find the critical values for all 3 of these factors. So x minus 2, the critical value is positive 2. X plus 4, your critical value is negative 4. And x minus 1, your critical value is positive 1. Okay, this right here would make you think they're all open circles. Okay. Let's put these over here, x minus 2, x plus 4, and x minus 1. Okay, and we're going to use the same idea. The reason we can use the same idea because we know if all 3 of these are positive, a positive times a positive divided by positive, that's going to be positive. Let's say they're all negative. 3 negatives would give you a negative. If any 2 are positive and 1 is negative, you get a negative. If any 2 are negative and 1 is positive, you get a positive. So just knowing, since these things are multiplied or divided, and we're comparing to 0, so we only care if it's positive or negative. So once we know that these are positive or negative, then we can figure out that the entire quantity is going to be positive or negative. Okay, let's pick a value of x less than -4. It's negative 5. Negative 5 minus 2, negative. Negative 5 plus 4, negative. Negative 5 minus 1, negative. Okay. Pick a next value between -4 and positive 1 to test this interval. It's a 0. 0 minus 2, negative. 0 plus 4, positive. 0 minus 1, negative. Okay. Pick the next value between 1 and 2. 1.5, 1.5 minus 2, negative. 1.5 plus 4, positive. 1.5 minus 1, positive. Pick a value of x greater than 2. Let's say 3. 3 minus 2, positive. 3 plus 4, positive. 3 minus 1, positive. Okay, so when x is less than -4, we've got 3 negatives, which gives you a negative value. When x is in this interval, we've got 2 negatives and a positive, which gives you a positive. This interval, 1 negative, 2 positives, we get a negative, and all 3 positives give you a positive. We want greater than 0, so we want the positives. Okay. So our solution is going to be set of all x such that x is between -4 and 1, or x is greater than 2. Interval notation would be -4 to 1, union with 2 to infinity. Okay. And let's do this one. There's one more unique thing that comes up in this next problem. Okay. So we've got, let's find our critical values. That would be 1/3. That would be -5. That would be +6. Okay, now this would make you think they're all closed circles. However, you have to be careful with this one. If you end up with a 6 in the denominator, that makes a 6 in this quantity. 6 minus 6 is 0. And it makes this thing undefined. If this thing is undefined, it certainly cannot be part of the solution. So because this is less than or equal, these two are going to be closed. Anything that makes your denominator 0 will never be part of your solution set. So we have to put that aside. Okay? So we've got 3x minus 1, x plus 5, and x minus 6. Okay, so when x is less than negative 5, let's say negative 6. 3 times negative 6 minus 1, negative. Negative 6 plus 5, negative. Negative 6 minus 6, negative. Between negative 5 and positive 1/3, let's say 0. 3 times 0 minus 1, negative. 0 plus 5, positive. 3 minus 6, negative. Between 1/3 and 6, let's pick 2. 3 times 2 minus 1, positive. 2 plus 5, positive. 2 minus 6, negative. Greater than 6, let's say 7. 3 times 7 minus 1, positive. 7 plus 5, positive. And 7 minus 6, positive. Okay. 3 negatives gives you negative. 2 negatives and a positive gives you positive. 2 positives and a negative gives you negative. 3 positives gives you positive. We want less than or equal to 0, so we want the negatives. Okay, so there's our solution on the number line. Set of all x such that x is less than or equal to negative 5, or x is between 1/3 and 6. Interval notation would be, and you don't have to do both, this answer would be perfectly fine. If I ask for interval notation, you've got negative infinity to negative 5 in union with the interval from, include the 1/3, so it's a bracket, to 6 in parentheses, so you don't include the 6. All right? Okay, now the last two at the bottom. These are a little more complicated. Notice you're not comparing to 0. And we can't multiply both sides by one of these things. If you multiply both sides by, let's say, x plus 1, what's the problem? Well, is x plus 1 a positive number? Possibly. It's a negative? Possibly. If you multiply both sides of an inequality by a negative number, you have to flip the sign. So if you multiply by a variable, you don't know if that variable is positive or negative. So you cannot multiply both sides of the equation by an unknown. You don't know if you need to flip the sign or not. Okay? So instead of multiplying, we're going to subtract it over to the other side. So 2 over x minus 2 minus 1 over x plus 1 is equal to 0. Not equal, greater than or equal to 0. Okay. That helped us with one of our two criteria for being able to do this problem. We're now comparing to 0. The problem is we're subtracting two quantities. We're not multiplying and dividing. If these are both positive, we don't know if the difference of two positives is positive or negative, so that doesn't help us. We somehow have to combine these, which means we have to get common denominators. Okay, so this thing right here, a common denominator is going to be x minus 2 times x plus 1. So we're going to multiply this first quantity. Let me move it over a little bit. We've got 2 over x minus 2. So I'm going to multiply by my clever form of 1, which is going to be x plus 1 over x plus 1. And I'm going to move this over, give myself a little space, minus, and this thing is going to get multiplied by x minus 2 over x minus 2. It's greater than or equal to 0. And so now we have a common denominator, x minus 2, x plus 1. On the top, we get 2 times x plus 1 minus 1 times x minus 2, greater than or equal to 0. Okay, distribute that out. 2x plus 2 minus x plus 2 over x minus 2, x plus 1, greater than or equal to 0. That's plus 2 and plus 2, so 2x on the top, we get x plus 4. And on the bottom, I get x minus 2, x plus 1. Okay, all that work, but now we have the criteria set, so we can use this chart, we can use this method. Okay, so let's try number 1. The critical values are -4, +2, and -1. And it looks like they're going to be closed circles. However, anything that makes your denominator 0 has to be open. So 2 has to be open, and -1 has to be open. Okay, we've got our factors of x plus 4, x minus 2, and x plus 1. So let's say x is less than -4, -5. We get a negative, negative, negative. X is between -4 and -1. Let's do -2. Positive, negative, negative. Between -1 and 2, that's 0. 0 plus 4. Positive, 0 minus 2. Negative, 0 plus 1. Positive, greater than 2. Let's say 3. 3 plus 4. Positive. 3 minus 2. Positive. 3 plus 1. Positive. Okay, 3 negatives gives you a negative. 2 negatives gives you a positive. 1 negative gives you a negative. 3 positives gives you a positive. Greater than or equal to 0 and 1 the positives. So here's our solution on the number line. Set of all x such that x is between -4 and -1. Notice I'm including the -4, don't include the -1. Or x is greater than 2. The interval notation would say -4 to -1, union with 2 to infinity. Okay. And the last one, I think I'm going to do this on the back side. I have 1 over x minus 4. Something else comes up in this one that makes this one interesting. Okay. Is less than 1 over x plus 2. Okay. So again, I'm going to subtract to the side 1 over x minus 4. I'll leave some space. Minus 1 over x plus 2. It's less than 0. Leave some space to give common denominators. We need to combine these. So I've got x plus 2 over x plus 2. I've got x minus 4 over x minus 4. So my denominators match now. I've got 1 times x plus 2 minus 1 times x minus 4. X plus 2, distribute that -1 minus x plus 4 over x plus x minus 4x plus 2. So the x's go away. Oh, this one, I thought this one turned out a little bit worse than it did. I just get 6 on the top. X minus 4, x plus 2, less than 0. Okay, now notice there's only 2 things to check. So we've got a +4 and a -2. +4 makes this 0, -2 makes this 0. They're kind of both the open circles because of this, but also because they're in the denominator. It's -4, x plus 2. Less than -2, let's take when x is -3. -3 minus 4 is negative. -3 plus 2, negative. Pick a number between -2 and 4. Let's see, 0, 0 minus 4 is negative. 0 plus 2 is positive. Pick a number greater than 4. Let's say 5. 5 minus 4, positive. 5 plus 2 is positive. Okay, so 2 negatives makes a positive. 1 negative makes a negative. 2 positives makes a positive. We want negatives, so we want this right here. So we want the set of all x such that x is between -2 and 4. For interval notation, we'll simply say -2 to 4.